Your packet, page 6, oh, it's part, no, it's part 2. Ooh, I'll have to rename that. Okay, page 16 in your packet is where we're going to start. And what we're going to learn about today, two things. We're going to learn about how to read a computer printout and how to find all the things that you need to know on a computer printout. And then after we do that, we're going to learn about 2 new phrases that you have to know how to say and interpret. You know, we have 4 songs for the other ones. Well, we're going to add 2 new songs for those. One of them is the standard deviation of the slope, and one of them is the standard deviation of the residuals. So we're going to kind of discuss what those things mean and learn the words to interpret those 2 things. All right, so let's do this. So this computer printout is from a common program that you would see if you were in a business and looking for this, and it's called Minitab. And so this is a printout of a tree analysis and about the volume of the tree and its height. Okay, so trying to predict the volume of the tree from its height. So typically on other kinds of computer printouts, this doesn't show up, this type of, usually you don't see the equation written there. This one does happen to have it on there. Be careful because they don't have the prediction hat. Okay, so that's something that you have to know needs to be there if you are asked to rewrite this. Okay, and so now let's talk about all these other numbers that are in here. There's 2 lines. One of these lines has to do with all y-intercept information, and one of these lines has to do with all of the slope information. Okay? So the constant, the one that is labeled constant, is the line that has to do with the plain number in the equation. So do you think that's information on y-intercept or slope? Y-intercept. Okay? So that means this top line, the line that is labeled constant, is all the information you need to know about a y-intercept. Okay? And really, the most important thing that you can get from this line is this first number. It says coefficient. So these numbers are the numbers that are in the equation of the line. So if it had not given you the equation of the line right here, you're supposed to find them right there in that section that is, the column's name is coefficient. All right. So we can see that the y-intercept is negative 87.12, which, do you think that makes sense that when the height of a tree is 0, that the volume of it is negative 87? No. See, the y-intercept often does not make sense. Okay? All right, moving on. This next column has to do with standard error of the coefficient. They are calling it standard error, meaning how much it is off from what is the average or the normal. That is another way of saying the standard deviation of the coefficient. Okay? Now, we are not ever interested in the y-intercept. I mean, it doesn't even make sense throughout the entire line. So we're not interested in that data. We are not interested in this t-score or this p-value. Those things we're going to learn about what they mean next semester, but we are never ever going to need them for y-intercept because those would have to do with predicting what the y-intercept is. And we don't care ever about what it is except for its value. All right. The next line is entitled, in this case, height. So what do you think this means? What is this height in this problem? It's the x variable. Okay, so this height is our x variable, so therefore the coefficient to that is the slope. So that means this line here is all about slope. Namely, this coefficient means that the slope is 1.5433. So that is the actual value of our slope up in the equation. Okay? Now, we are interested, and we're going to learn about what this slope standard deviation is. And so this slope standard deviation is 0.3839. We'll talk about what that means. This t-score and p-value we'll eventually use, but not until next semester. So I'm not going to cross those out, but we don't use those yet. All right, so at this time, let's actually kind of about what this standard deviation of the slope means. So what we have going on here is, first of all, what is standard deviation in general? Perfect. The average distance that the data is away from the mean. Okay. So here's what's happening with this stuff here. We took a sample, I got some data, and then I got a slope, and the slope that I got was 1.54. All right, well, somebody else is going to get some data. So let's say Jake gets some data, and he puts it into the calculator, and he calculates the equation of the line. Is his slope going to come out exactly like mine? His prediction line will be different. It may even have a different y-intercept. No, so his slope could be a little different than mine. All right, let's say that we got Amanda going, and she goes and collects some more data. Amanda goes, collects some more data. She goes, puts it in her calculator, gets the equation of the line. Is her slope of her line going to be just like mine and Jake's? No. So all of these slopes are varying a little bit. So from sample to sample, our slopes are varying. Okay, so from sample to sample, our slopes vary. All right, and I think that's easy to understand why. Well, guess what? I want to know, how much is it okay for those slopes to differ from each other to be reasonable? You know, what's a reasonable amount to expect that Amanda's slope might be different from mine, or Jake's slope might be different from mine? How much off can this be to be okay? Well, up to 2 standard deviations. Well, what's the standard deviation? It is the average distance that when you sample many times and you get lots of people doing lots of different equations of the lines, it's giving me, on average, about how much those slopes might differ from each other. On average, about how much those slopes might differ from each other. Okay, that is called the standard deviation of the slope. Sometimes you'll see it as standard error of the slope. All right, and so then I have because you're going to be interpreting it later and writing it out on your assignment, because you don't have this in your packet, but here is the words to the song, and I'm going to sing it for you right now. I also have it posted on the board so later you can reference it. And you might want to take a picture of this with your phone later. So I'll come back to it. But, we're like, oh no, back to class? Okay. So that number in this case, see, is 0.3839. So the slope I got was 1.54. And, you know, you can add or subtract 2 of those standard deviations, and that's kind of a range of slopes that I think would be okay. All right? Past that, I'd consider it strange and being an outlier. All right, moving on. Okay, this next line, this S here is the standard deviation of the residuals. Okay, standard deviation of residuals, and that's the other thing that you need to know, and you need to know the words and the phrases of how to interpret. So let me draw you a picture of that. And let's see here. So here's what we have going on. It said it was 13.4, so I'm going to draw a picture of a residual plot. And so here's our prediction line. And I know going up 1 standard deviation is 13.4 and down is minus 13.4. And 2 standard deviations is 26.8. And then past there is outlier. And then I got my minus 26.8. Okay, and then I got whatever that is. So that means that, you know, on average, the data is going to be within 1 standard deviation. And listen to this. I want you to notice the amount of data I'm putting within 1 standard deviation compared to now within 2 standard deviations. what do you notice about the quantity of data I'm putting within one standard deviation? What? Okay, there's more, and it is 68% of the residuals should fall within one standard deviation of the line. Okay, mind blown. So it's like a three-dimensional normal model that I expect not 68% of those residuals to be within one standard deviation of the equation of the line. Because see, this is kind of like the average, the prediction line, the average, okay, and so on. So then within two standard deviations is going to be our 95%, and so on, and 3, 99.7. Okay, so if we, let's take a step back and look at the original line. If our original line, was like this, then again, we would see more data clustered closer around it, and then less of it would be farther away. The farther away you get, the less data there is. Okay? All right, did you have a question? No, we shouldn't be saying yikes. Is there a pattern? I didn't. Oh, where? Did I really? Where? Oh, I know. And then I went back and I put some other dots in there so it didn't have a pattern. Yeah. Right? Is there a pattern in there now, or did I fix it so there's no pattern? Okay, there's not one. Okay. There started out being one, but then I tried to, fill it in so there wasn't one. Okay. All right. So that is the standard deviations of the residuals, about how far, on average, the actual data is away from the predicted, residuals, y minus y hat. So if I took every single one of these residuals and I averaged them, of course, if I just added them, they sum up to 0, but you would square them and then you would do all of that kind of stuff. So getting the standard deviation of those residuals, it comes out to be 13.4. All right, so I got another set of word phrases kind of for you to help on that. So this is to Michael Jackson's Billie Jean. I don't know if you know that one. So standard deviation of the residuals. And so this is the average amount that the actual y's vary from the predicted y's. That's essentially what it's saying. The average amount that the actual y's, the actual y value points, varies from what's predicted to become, varies from the predicted y. Average amount, the actual y, varies from the predicted y. That was to cut it down to just straight up words. Okay, it up. Okay, the last thing really that we're interested in is how to find that coefficient of determination and the correlation coefficient, our r and our r squared. Well, you will notice from our information here that all we are given is r squared. We are not given the r value. So, let's see. How do you think we could get r value if all we have is r squared? Square root it. Okay, so then we would take this r and we would square root not 35.8, but 0.358. And we get that number, whatever that is. I think it's like 0.5 something. I don't know. Somebody will click that out for me real quick. 0.5. I don't know. Somebody will tell me. And then, but something special. Watch out for the sign. Watch out for the sign, because when you're taking a square root, the sign is always going to be what? Positive. But our residual our correlation coefficient can be positive or negative. How do I know? It's just like with a thermos. When you put stuff into a thermos, how does it know if it's supposed to keep it hot or cold? I don't know. It just knows. Okay? What? No. The slope. Good job. Yes. So I would then look at the slope, because if you have a negative slope, then you have a negative correlation. And if you have a positive slope, you have a positive correlation. So then I'm going to come up here and look at my slope, and it is positive. Therefore, my correlation coefficient is positive. Did somebody finish that number for me? 0.598. Okay, thanks. All right. And then we would then interpret that as we know how to do. We have a moderately strong positive, so on and so forth. Okay. So essentially, I've walked you through. Oh, one last thing. R squared adjusted is never used in our course. Okay. I think that comes from like taking out outliers and then recalibrating. So they do put, it is something that shows up on the computer models, and you have to know that you do not use it. Okay? When they have AP grading guidelines, they will say it's marked down to partial credit if the person used R squared adjusted, and so on. So it'll show up. You need to know not to use it. All right. And then the rest of these notes kind of just take you through stuff, just kind of show you exactly what I've talked to you about. And turn the page. There's also your information about R squared, R, T, and P, which we don't use yet. And there's another example, which I'm not going to go through. So your assignment that you're going to do, but I need to add a couple little things to it. So take a look on page 18. So your assignment to do for me, pages 18 and 19. And so you can see that you're getting the information, coefficient of determination, correlation coefficient. I believe that the information that I'm interested in adding is on page 19, when question B on page 19 says, what is the standard deviation of the slope? It just asks for what is it, but I want you to, now that we have discussed it and did a song of it, I want you to interpret that standard deviation of the slope as well. So I would say something like, if I sample many times, I'd expect the slope I'd find of the relation between volume and height to be about 0.38, to vary about 0.38, whatever the units is, on average. Okay? And then part E says, what is the standard error of the residuals? What is this another name for? Standard deviation. Okay, I also want you to interpret that as well, since we have spent some time on discussing that. That's the average distance that the actual y value point, is away from the predicted to become its way from what it's predicted. Okay, well, sorry, that was a real botch of that. That was a real attempt to just kind of say this song real fast, and I totally botched that out, but anyway, there you go. I'll have that song on the YouTube shortly, and so you can then actually listen to it. All right, next section is the same way. Question B asks you, what is the standard deviation of the slope? I want you to interpret it as well. And question F, what's the standard error of the residuals? Interpret that as well. Okay? So basically, we know how to interpret them, not just find them. That's it. Okay, so the rest of the class, I'm going to have you work on pages 18 and 19.